Hi friends, I am Amit Kumar and welcome to Technical Education Classes. In this session of satellite communication, we will discuss two very important topics: forces acting on satellite and Kepler's law. And for regular update, please like, share and subscribe our YouTube channel Technical Education. Thank you. Forces acting on a satellite. हमारा जो सैटेलाइट होता है आर्टिफिशियल सैटेलाइट वो अपने पाथ में अपने ऑर्बिट में हमारे अर्थ के चारों तरफ घूमता रहता है और इस रिवॉल्यूशन के दौरान इसमें किस तरह के फोर्सेस एक्ट करते हैं इसी को हम लोग आज के इस सेशन में स्टडी करने जा रहे हैं। Artificial Earth satellites that orbit the Earth are governed by the same laws of motion that control the motions of the planets around the Sun. Satellite orbit determination is based on the laws of motion first developed by Kepler and later refined by Newton in 1665 from his own laws of mechanics and gravitation. Competing forces act on the satellite. Gravity tends to pull the satellite in towards the Earth, whereas its orbital velocity tends to pull the satellite away from the Earth. This figure shows a simplified picture of the forces acting on an orbiting satellite. In this picture, the gravitational force F in and the angular velocity force F out can be represented as F in equal to m into mu by r square and F out is equal to m into v square by r, where m is equal to satellite mass and v equal to satellite velocity in the plane of the orbit, r equal to distance from the center of the earth, that is orbit radius. Mu is equal to Kepler's constant or geocentric gravitational constant, that is equal to 3.986 into 10 to the power 5 kilometer cube per second square. Here we note that for F in is equal to F out. So from equating equation 1 and equation 2 we get velocity is equal to mu by r to the power half, that is satellite velocity in the plane of orbit. This result gives the velocity required to maintain a satellite at the orbit radius r. Here we note that for the discussion above, all the other forces acting on the satellite such as the gravity forces from the moon, sun and other bodies are neglected. Now we will study Kepler's law of planetary motion. Kepler's law of planetary motion. जोहान्स कैप्लर जर्मनी के एक महान खगोलिक वैज्ञानिक थे। 16वीं शताब्दी में डैनिश के खगोलिक वैज्ञानिक टाइको ब्रेह द्वारा कई एक्सपेरिमेंट किए गए थे। कैप्लर ने टाइको ब्रेह के इन्हीं एक्सपेरिमेंट्स को बहुत बारीकी से अध्ययन किया और इस स्टडी के बेसिस पर उन्होंने प्लैनेट के जो मोशन है उससे संबंधित अपने 3 बहुत ही महत्वपूर्ण नियम दिए। इन नियमों के आधार पर यह बताया जा सकता है कि सौरमंडल में ग्रहों की गति किस प्रकार से होती है। इस पर केप्लर ने पहले 2 नियम 1609 में दिए और तीसरा नियम लगभग 1618 में दिया था। Satellites or spacecraft orbiting the Earth follow the same laws that govern the motion of the planets around the Sun. Kepler's law of planetary motion apply to any two bodies in space that interact through gravitation. The more massive of the two bodies is referred to as the primary and the other the secondary or satellite. The laws of motion are described through three fundamental principles: Kepler's first law, Kepler's second law, and Kepler's third law of planetary motion. Kepler's first law or law of orbit. केपलर ने अपने इस नियम में बताया कि सभी ग्रह सूर्य के चारों तरफ दीर्घवृत्ताकार कक्षाओं में गति करते रहते हैं और सूर्य इस दीर्घवृत्त के किसी एक फोकस पर होता है. सो केपलर्स फर्स्ट लॉ स्टेट्स दैट द पाथ followed by a satellite around the primary will be an ellipse. An ellipse has two focal points as shown in the figure as f1 and f2 in the given figure. The semi-major axis of the ellipse is denoted by A and the semi-minor axis by B. So, the eccentricity A is given by under root A square minus B square by A. Now we will study Kepler's second law of planetary motion. It is also called law of aerial velocity. हिंदी में इसे क्षेत्रीय चाल का नियम कहते हैं. केपलर्स का यह नियम हमें यह बताता है कि ग्रह को सूर्य से मिलाने वाली रेखा यानी ग्रह को सूर्य के रिस्पेक्ट त्रिज्य वेक्टर समान समय अंतराल में समान एरिया तय करती है. यानी इस नियम के अनुसार प्रत्येक ग्रह का एरियल वेलोसिटी का मान हमेशा कांस्टेंट रहता है. So in this way Kepler's second law states that for equal time intervals a satellite will sweep out equal areas in its orbital plane focused at the very center as shown in the figure. Assuming the satellite travels distance s1 and s2 meters in 1 second, then the areas a1 equal to a2. The average velocity in each case is s1 and s2 meter per second, and because of the equal area law, it follows that the velocity at s2 is less than that at s1. This result also shows that the satellite orbital velocity is not constant. The satellite is moving much faster at locations near the Earth and slows down as it approaches apogee. Kepler's third law of planetary motion is also called law of periods. इसे हिंदी में परिक्रमण काल का नियम भी कहते हैं. Kepler's third law stated simply is the square of the periodic time of orbit is proportional to the cube of the mean distance between the two bodies. The mean distance is equal to the semi-major axis A. For artificial satellites orbiting the Earth, Kepler's third law can be written in the form AQ is equal to mu by n square, where n is the mean motion of the satellite in radians per second and mu is the Earth's geocentric gravitational constant, where mu is equal to 3.986005 into 10 to the power 14 meter cube per second square. At the next class, we will study Earth orbiting satellite parameters. Thank you for watching.